When a car must make a sudden stop, it often leaves skid marks on the pavement. Is there any way to tell from the skid marks how fast a car was going before you put it on the brakes? There is, right? If they tell you how fast they were going, you think if somebody's going to get in a wreck, they're going to be honest with the police officers about how fast they were going? If they weren't speeding, they may, but maybe if they have to go to court or anything, they need a proof of how fast they were going, right? So this equation right here can be used to estimate the speed a car must have been traveling in order to make a skid that measures d feet in length. The f in the equation is a coefficient of friction that depends on the road conditions. Okay? For a typical street, we're going to use f equals 0.6. We can talk about what would make this change, and that would be things like if the road was wet or icy, if the road was dirt or pavement, if it was windy, right? That would even affect probably stuff like that, okay? Not so much that it would affect the road, it would affect your car, okay? So when we put in 0.6 for f, we end up getting s equals the square root of 30d, right? Not 30. Why did I write 30? How about 18? Okay, 18d. Pretend that's a nice 18. Okay? So we need to fill in this table if d is 20 and 40 and 60 and so on. So each one of you pick one of these. Don't everybody pick the first one, but each one of you pick one of these and tell me what it is when you get it. 200 is 60. 20 is what? Yeah, I do get 360 underneath the root, but then I have to take the root. So can we say 19? Approximately 19. If we're rounding to the nearest miles per hour, we can say 19, right? Anybody do 40? 52 for 150? Okay, thank you. So 42 for 100? Okay. I got 3 more. Somebody that hasn't answered yet. 80 is 38. 60 is 33. You could actually figure it out, right? What 40 would be by saying 18 times 40 and then taking the square root of that. So 27. Okay. So let's take these values from this table and plot it onto our graph. Okay. So when x is 20, y is 19. So I go almost all the way up to 20, right? When x is 40, I go to 27. So it's not quite to 30. So maybe right there. When x is 60, I can go to 33. It's above the 30, but not quite half, right? When x is 80, I can go to 38, so not quite to 40. When x is 100, I go to 42, so just above the 40. Uh-oh, I've been counting by 20s this whole time. Now I got to go to 150. There's 100, 120, 140, 160, so it's just halfway in between, right? And then I got to go up to 52. Well, there's 50, so 52 is going to be right above it, right? And then when x is 20, y is 60. $200, thank you. What did I say, 20? Okay. When x is 200, y is 60. Thank you. So, logically, in the context of this problem, is there one more point I can plot on my graph? What is it? 0, 0, right? The distance of the skid mark would be 0 if I was going 0 miles an hour, right? So then I have this really pretty square root function, don't I? Okay. Can I say with certainty that's a square root function? How? What's my y equals, guys? Square root of 18d, or square root of 18x, depending on what you're thinking about. Okay, so on my calculator, I'm going to go ahead and start a new document. No, I don't want to save my old one. And I want a graph. Okay, and I want to put in tab, not tab. I'm already at tab. Great. So I'm going to put in the square root of 18x. I must have really messed up. It doesn't even look like that at all. Oh, my window's not right? So I could actually read my directions and say, oh look, we have to fix the window. Menu, window, and I need to fix my Windows settings. Okay? So I'm going to use the Windows settings that they suggest. My X minimum starts at 0, and I need to go all the way to 220. Remember your tab in between to make it easier to get there. And I want to count by 20s. Tab. And my Y minimum, I want to start at 0 and tab to my Y maximum, which is 70. And I tab because I want to count by tens. Oh my gosh, I am amazing. I mean, we are amazing. Okay, so far? So, use the trace and the table features to answer the questions that follow. So I'm going to go ahead and start at my trace. I'm going to do window, trace. I don't know why I said window. Menu is what I meant. And I want to graph trace. Okay? So, a dog ran out in front of your car. And you slammed on your brakes. It wasn't a cat. And you left a 15-foot skid mark. How fast were you going? Well, what do you know? Do you know your distance or do you know your speed? You know the distance, right? 15 feet. So my x value has to be 15. So if I actually move my left and my right arrow around, look what happens to the x value. It's changing by 5s. Can I get to 15? So what does that mean? When my skid mark was 15 feet long, I was going 16.4 miles per hour, right? Yes? Okay. So a second car almost ran into the back of you, but was able to stop after making a 108-foot skid mark. If the speed limit was 45, was this driver speeding? Can I use my trace and get to 108? I can go, okay, well first let me go look at 110, because I can't get to 108 because it's counting by 5s, right? So there's 110 and there's 105. 105, 110. So what do you think? Well, I got to know the distance first. I know this. I got to know the speed. I know the distance is 108. Why do I have to? Because it asks me. Okay, it does ask me were they speeding or not, but it also asks me the speed. So I have to know what the speed is. Is there another place I could go to look to actually find 108? I could go to the table. Control T, and then all I have to do, it's not really hard, I just have to sit here pressing the down arrow, right? Holding it down until I get where? 108 for what? The x, right? The distance. Okay. Da 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 da. 44 what? 44.1 what? Yes, sir. Let me look at it. Does this make sense? Now that we know what the speed was, if the speed limit was 45, was the driver speeding? Are you talking about the table? See, yours is counting by 3s for some reason. I don't know why it's counting by 3s. That's cool. Oh, because you said auto. On your table settings, you left that at auto. We made ours 20. Okay, so that might be that might be why it's doing that. Okay? It's fine. I'm glad you could see it. That's fine. Okay? So, what's our answer for number 2? What's our answer for number 2? Because of the work I've done already finding out what the speed was, is it okay if I just say, no, he was not speeding? I could say he was going 44.1 miles per hour when the speed limit was 45, so he was not speeding, but I've actually already done that by the work I did over here with my trace feature or looking at my table. Okay? So what about problem 3? A third car was going 48 miles per hour when it slammed on its brakes. How many feet will it take this car to skid to a stop? What do we know? We know 48. We know that's the speed, right? I know 48 miles per hour. Any idea how I'd figure this out? Oh, we can go in our table? So what am I looking for in my table? 48 where? In the Y. Oh. So what would happen? I get that it's 128 feet. I forgot to put feet right here. I get that it's 128 feet. I agree with you wholeheartedly. Okay? Because that happened to be one of the places where I have a whole number of 48. But what if that was not there and it went from 47.8121 to 48.1871? Am I finding exactly how fast it's going at 48? So I have to know another way. Okay? We got lucky in the fact that it was on the table. It's not always going to be nice, pretty numbers that show up on the table. So is there any way to use the equation that I have and the information I have from this problem to set something up like that? So 48 is the speed, right? And that would equal the square root of 18d. Okay? Turn this over on the back real quick, please. 48 equals the square root of 18d. So what are we doing today? Solving square root equations. And how did you know that? Because you read it on the sideboard, right? It's not a surprise what we're doing. You come in here and look. There it is. If we have to solve square root equations today, guess what we're going to learn how to do? Solve square root equations. Okay? There's 4 steps that you need to know how to do. 4 steps. The very first step isolate the radical. Okay? So I'm saying, is the radical by itself? Well, I'm not talking about what's inside the radical. Remember yesterday when we talked about transformations, we were talking about inside and outside? I'm saying anything outside of the radical has to be gone. The radical has to be by itself. So if I cover up this radical, is there anything else on this side of the equal sign? No, then this radical is isolated. Okay? Number 2, if I have a radical, how do I get rid of the radical? Square it. So I'm going to square both sides. Well, what's it look like when I square both sides? Did I show you the shortcut the other day, by the way, to square 48? Okay, I'm going to show it to you today just in case. What do I get on this side? Let me show you something real fast. We're taking a commercial break. Let's say I have the square root of 25. What is the square root of 25? 5, and I square that. What's 5 squared? 25. What if I have the square root of 121? What's that? And then what if I square that? What do I get? 121. So if I have something I'm taking the square root of, and then I square that, what am I going to end up with? Whatever I started with, right? So if I have 18d and I'm taking the square root of it and then I'm squaring it, what do I end up with? 18d. Okay, you ready for the shortcut? I mean, it's not really a shortcut if you have a calculator, but just in case you don't have a calculator. Let's do 40 times 40. We're squaring 48. What's 40 times 40? 1600. Now let's do 8 times 8. 64. Now we have to do 40 times 8 times 2. Well, 40 times 8 is 320. 320 times 2 is 640. And if I add that up, 10, 3, 2,304. And just so you don't think I'm making that up, 48 squared, 2304. Okay? So, did we square both sides? And we got that, right? So what about 3? Any ideas what 3 is going to be? Solve. Divide both sides by 18. D equals 128. Now for step 4. Check. So I have 48 equals the square root of 18 times 128. What is the square root of 18 times 128? 2304. What's the square root of 2304? Does 48 equal 48? Check. So not only am I plugging my values in to check my work is correct, I'm literally checking my work. Okay? Any questions about that? These 4 steps are what we're going to use every time when we solve a square root equation. Okay? Look at your other page, please. So the first example that we just did is right here. Okay? So let's do these 2 examples right here and right here. You ready? First one. First step is the radical by itself. If I cover it up, is there anything else on that side of the equal sign? The 5, right? What do I do with the 5? Subtract 5 from both sides. Good. So I get the square root of x minus 3 equals 4. Now what? Is the radical isolated? Yes. So now square both sides. What do I end up with on the left-hand side of the equal sign? X minus 3. What do I end up with on the right side? 16. Did I square both sides? Now, simplify and solve. So, add 3 to both sides. X equals 19. Is that the right answer? Prove it. 5 plus the square root of 19 minus 3 equals 9. What is 19 minus 3? 16. So I have 5 plus the square root of 16 equals 9. What is the square root of 16? So 5 plus 4 equals 9? Yes, it does. So then I go back and box my answer because I know it's right. Okay? Any questions about this? What about the second one over here? Isolate the radical. Is it isolated already? No, we have to add 3 to both sides. This is where you have to be so careful and know what you're doing. Otherwise, sometimes your math teacher wants to strangle you. Sometimes just general math teachers, not specific. Square both sides. What do I have on the left-hand side? What do I have on the right-hand side? That's what I was afraid you'd say. If your math teacher was so inclined, she might feel like strangling you. Do we just get x squared plus 9? What does it mean for something to be squared? Multiply it by itself, so x plus 3 times x plus 3. What do I have to do with that? Oh, distribute. X squared plus 3x plus 3x plus 9. Please, please, please don't forget it. That's why we spent so much time on it in the polynomial section. So what do I actually end up with on this side? X squared plus 6x plus 9. Okay? Any questions? I don't want to strangle anybody right now. It might hurt my hands. It would probably hurt my hands. Not as much as it hurt your neck. What kind of problem is this? A squared one, which is called... it starts with a Q. Oh, quadratic, yes. And you didn't want to get strangled again? Okay. So, if it's a quadratic, what do we have to get it equal to? 0. So I need to subtract x here and subtract x here. I need to subtract 5 here and subtract 5 here, correct? 0 equals x squared plus 5x plus 4. So how do you want to solve this? I think Larry wants to factor. Now, I heard some people say quadratic formula. That would work. But remember, if we can factor something, think about how much quicker it is than quadratic formula. Guys, can you think of two numbers that multiply to be 4 and add to be 5? How about 1 and 4? Okay? X plus 1, x plus 4. If my two factors multiply together to give me 0, what has to be true about these? One of them has to be 0, right? And we take care of that by making them both equal to 0. Remember this? I mean, we just did it like last week. So x equals -1 and x equals -4, right? Okay. Now what? We got to check them, right? Okay. So if I check the -1, I have the square root of -1 plus 5 minus 3 equals -1. So -1 plus 5 is 4. The square root of 4 is 2 minus 3 is -1. 2 minus 3 is -1. Does -1 equal -1? Yep. Now -4, right? Square root of -4 plus 5 minus 3 equals -4. So -4 plus 5, 1. The square root of 1, 1 minus 3 is -4. What? Did I do something wrong? No, I didn't, did I? 1 minus 3 is -2. -2 does not equal -4. That's not a solution. But I don't understand how I would get two solutions and one of them doesn't work. Not only does it just happen, can I show you? What does a parent function of a square root function look like? What is that? New document. No, I don't want to save. Graph. Square root of x. What does it mean for something to be a solution? Graphically. That's where it crosses the x-axis, right? How many times is a square root function going to cross the x-axis? Is it ever going to curl back around over here? No, we talked when we very first talked about the graph of it. We know it keeps going that way, right? So how many times can this cross the x-axis? Either 1 or 0. Now, I got 2 solutions because in the process of solving this, my problem was a quadratic. And if I'm solving a quadratic, how many solutions should I get? 2, right? Most of the time, right? Unless it's a double root, but we won't even go there for now. We're just saying if we get solutions, we should get 2, right? So that means if I'm doing a quadratic, if my problem turns into a quadratic and I get 2 solutions, what do you know? At least one of them won't work, will it? Is it possible for neither one to work? Because, where's my paper? It could look like this, right? How many times is that going to cross the x-axis? Never. Okay? So just keep that in mind when we're doing this. We should get one answer. Okay? Are there any questions?